Hi, my name is Fernando. I'm a professor at UFMG Brazil, and today I will present to you AnghaBench, which is a collection of benchmarks. And what's unusual about this suite is its size. It contains today more than 1 million compilable functions. These programs are all written in C, and they have been mined from open source repositories. The programs in our benchmark suite can be compiled by any major C compiler. That includes mainstream compilers like Clang, GCC, and ICC from Intel, for instance. However, these programs don't run. Nevertheless, having a huge number of compilable programs is good for many things. Additionally, an important contribution of this work is the recipe to produce benchmarks automatically. This recipe includes the techniques necessary to gather the benchmarks from open source repositories and the techniques to reconstruct the programs so that they are guaranteed to compile. For this process of reconstruction, we use type inference. And that's the same style of type inference that's used in functional programming languages. And AnghaBench is publicly available and it's ready to be used. You can get the collection from our website. There you can download different assembles of benchmarks, like programs with a single function or programs with multiple functions. Some of the benchmarks have also been organized into a browsable database where you can search by similarity, for instance, and you can find several studies that we have carried out in this code base. But something that you might be wondering is, what is it good for to have so many compilable programs if they cannot run? In this paper, we show how to use this huge collection of benchmarks to train compilers for code size reduction. However, much more can be done with it. We can use the collection to test compilers. For instance, we can use AnghaBench to find sequences of compiler optimizations that might crash the compiler. And not only compilers, we can stress test tools that read programs in general. For instance, friends from UFP have been using AnghaBench to know how many programs would fit into particular types of FPGAs. And we can use the collection to know more about programs that we find in the wild. For instance, out of a bit more than 1 million programs, we have found out that 986,000 have chordal interference graphs. That means that the problem of assigning physical registers to variables can be solved optimally for 95% of them. But in this paper, we show how to use AnghaBench to train a predictive compiler that's good for compressing programs. Predictive compilation has become fashionable in recent years, and that's the custom treatment of programs. Usually, a compiler applies the same sequence of optimizations on any program. For instance, if we consider -OS in Clang, then we get these optimizations. That's a lot of optimizations, and yet they might not be good for every program. For instance, let's consider this code here. What it does is not very important. If we give this program to opt-OS, then it produces an LLVM intermediate representation with 74 instructions. But let's use instead a different sequence of optimizations. We shall use this one with 9 optimizations. In this case, we obtain an intermediate representation with only 22 instructions. To see how we find the sequences, you can read our paper. We have several results in the paper. For instance, we could produce binaries for some AnghaBench programs that are 10% smaller than Clang -OZ, and our predictions could outperform even function merging by sequence alignment in some cases. For instance, in Blowfish, one of the programs in AnghaBench, FMSA cannot reduce code, whereas we reduce it by 18%. Anyways, you can find more about these results in the paper. And in addition to the paper, we have also a technical report describing our benchmark suite. And if you are interested in the work, please get in touch.